Let's imagine that I'm working with a penguins data set. I'm going to go ahead and take a look at the basic data here. I see that I have species, island, bill length, bill depth, etc. I'm also going to go ahead and run the describe method to get a little more oriented in the data set. Now it looks like species actually has 5 unique values. And I remember my colleague saying that there should only be 3, so we may actually have a data quality issue. To get a sense of that, I'm going to go ahead and run value counts. All right, so it looks like sometimes chinstrap is entered with an extra P and the Adelie is sometimes missing an E. I'm going to go ahead and loop this result and start fixing this. So I'm going to go ahead and run the string replace code, and then we can see that this old result here has actually been looped to my left, so I get real-time feedback on the correctness of my string replace code. Let's go ahead and see if we can fix the next typo. All right, and it looks like I actually didn't quite fix the issue. So I'm going to try again, but it's a good thing that DataChimp was there to give me feedback. So I think I fixed it. Let's try one more time. All right, great. So now it looks like we're down to 3 species, which is the correct amount, and we've eliminated the data quality issues. So since we fixed the data quality issue here, we're probably going to want to let our teammates know about the issue. And more importantly, we actually want to make sure we detect this data quality issue going forward. And we want to make sure that our teammates don't accidentally use bad data in their analysis. So to do this, I'm actually going to start by creating a persisted data frame that has a running count of unique species of penguins. So first, we're creating an empty quality checks data frame, which has a single column, which is the number of distinct species, and no values. And this is just the default value that we return if we look for a persisted data frame under the name quality checks, and there hasn't been one that's been created yet. Next, we'll actually compute the number of unique species in the penguins data frame, and then we'll create a new data frame that holds this result and append it to the data frame that we already grabbed with read persisted data frame up here. And so once we've appended these two things together, we're basically creating this running count of the number of unique species. So the last step is to simply call dc.persistdf for persist data frame, and we're going to pass in the newly created data frame and give it the name quality checks. So I'm going to go ahead and run this, and we'll see that initially there was 5 distinct species, and then after that there was only 3. And that reflects the change that we actually just made to the data. Now I actually want to run this every day, because we want a daily running count of unique species. So that's been scheduled. And next, I want to create and share a function that my colleagues can use to check on the data quality of the penguins data frame. So there it is right there. I'm going to go ahead and run it, and then I'm going to share this with my colleagues. And then finally, I'm going to write some code that's automatically run whenever a teammate starts a new analysis. And that code will alert them if there's a data quality issue, and it'll tell them to use this new function that we've shared. So let's run that. All right, so let's quickly walk through this. So first, it's grabbing the quality checks persisted data frame, and if the number of unique penguins species is greater than 3, it'll return this string, which is actually a markdown string. Otherwise, it'll return nothing. So we want to make this run automatically whenever somebody starts their analysis, and so I'm going to click this automate button. Now let's test this out. I'm going to go ahead and refresh the page. All right, so I'm going to run penguins, and we can see that our data quality message actually shows up, and it tells us which function to use to check the data quality issues. So we'll use that. We'll pass in penguins, and there we have it. So now our colleagues will automatically be notified if there's data quality issues, and they'll have a function they can use to easily see what's going on. I'm going to go ahead and dismiss this. And now that we've addressed the data quality issue, we can actually get back to analyzing the data. So I'm going to go ahead and type penguins here. And I'm going to loop this because I like to have the full table kind of rerunning every time I make an update or see a visualization. Now I'm actually curious about the relationship between bill length and bill depth. So I'm going to go ahead and click this scatter plots button. And then I'm going to just select the columns that I'm interested in. So here I'm interested in bill length, bill depth, and flipper length. I'm going to run this. Now when I do, I actually get scatter plots for every combination of columns that I said I was interested in. Now the visualizations that DataChimp generates aren't dumb images. They actually understand the code that generated them and their relationship to other artifacts within the IDE. Let me show you what I mean. In this first visualization, I see that there's a negative relationship between bill depth and bill length. And that's kind of counterintuitive because I would expect that the deeper a penguin's bill is, the longer it would be. I also see that there's some clustering in the data though, and I wonder if this relationship will inverse if we color the data points by species. To do that, I can actually send the code that generated this visualization back into a cell. And once I've done that, I can select the species column and then color by that here. So now I can see that the relationship's actually what I would expect, that the longer a bill length is, the deeper it is. Now there's a point on the bottom here that's kind of far away from the cluster, and I'm wondering if there's an outlier or something odd going on with the data. When I hover over the data point, the looped table automatically scrolls to the corresponding row that relates to that data point. And I can go over to it and look at the other column values and see that it was collected in 2009. And if my memory serves, that's actually when we did have some data quality issues. And so that actually could explain why that point's far away from the rest of them in the cluster. These buttons here are actually customizable. We call them applets. They're collections of pieces of code that automatically show us things. And so I can show you the code that actually is responsible for this scatterplots button here. Let's take a look. So I'm going to click into the scatterplots applet, and it has a single automation. The code that powers these automatic visualizations, it's just standard Python code. And you can actually share these applets and automations with the community of data scientists and hack on the data IDE together. And so here are some example applets, and you can see that they're starred. It's possible to have conversations about these things and to kind of clone them into your own IDE. So that's DataChimp. If that sounds cool, go ahead and sign up for the beta below.